All right. Sorry to disappoint you, but there's only one assignment left.
Oh no.
It only has 10 drawings.
What?
Okay, I'm just kidding. I don't want to correct 10 drawings times 24 people. We are now here. Session 8, week 8, May 23rd. I'm going to talk about welding symbols and weldment drawings. I'm going to have you do 2 weldment drawings. Chances are you won't get into weldments unless you're in a welding environment. And basically, we drafters know just enough about welding and symbols and symbology to be dangerous. And basically, the welding people go, drafters don't know anything about welding, which is probably true, unless you've actually done welding. And we do the best we can with the symbols. Please stop printing, because it's going on tape. So unless you're in the field, we can basically kind of put a couple welding symbols on there, and a welding person is going to know how they're going to weld anyway. But you need to know at least a little bit about welding symbols, because you never know what's going to turn up in an interview session. They might ask you, well, have you ever done any kind of welding symbols? And at least you can say yes. You don't have to say not very much, but you can say yes. And you've been exposed to it. Then, next Tuesday is an open lab to complete assignments. You have been given back some red line drawings for trolley assembly and belt tightener, a couple of you. The Tuesday after that, June the 6th, any and all first submission assignment drawings are due at the end of class. So that incorporates some of you, not all of you. And then the Tuesday after that, June 13th, all corrected red line drawings are due at the end of class. That is it. No drawings will be accepted after that point. Which means you have 4 class sessions or 4 weeks to get everything done. If you get it done before then, you don't have to show up on June 13th. You might not even have to show up on June 6th if you get all your work done. Otherwise, some of you will be keeping me company while I correct drawings. All right? Questions? Everything's well with the world? Good. All right. In your textbook, which we have not touched much, we've done a couple of the working drawing projects out of there. In the appendix is, let's see, page 673, 674, 675 is kind of sum and total of the textbook. Oh, that's good. That's perfectly clear, right? Everybody needs to go to the eye doctor.
That wouldn't be as clear.
They'll probably bring in a new projector next year after I'm done. And it'll probably be crystal clear, and after all of you are done. That's just the way it works sometimes. There's some basic welding symbols, and that's pretty much what we have to deal with in welding. Oh yeah, and before I forget, there's been another job come through, email-wise today, so I put it up on the board. That's the 4th one in a week. And plus Aerotech's gotten a hold of me and interested in having you sign up with them so they can collect their finder fee, placing you in a job. But hey, you know, every little bit helps. All right. A fillet weld. A fillet weld is basically a right angle weld. And a couple of things to realize about fillet welds. If the fillet symbol is on the bottom of the horizontal leader, that means that that weld is applied to the arrow side of the welding symbol. Because you can have a fillet weld on the top side, which means it's on the other side from where the arrow is pointing to when you put a weld symbol on. I might even help you out by what the welding symbol should look like on the drawing, but we'll see. Maybe I'll make it a mystery. What you need to know is that this is a 45-degree angle, and this needs to be sized appropriately for the size that you're drawing. The size can vary a little bit. On some of the weldment drawings in the past, some of the students have used SolidWorks or Inventor and created a 3D model because I believe, if I'm remembering correctly, there's some welding symbols that automatically come up in SolidWorks. You're welcome to use those to practice with those programs and putting, I'm not really thrilled with what they come out to be, but that's okay. You know, I can live with it. And that's basically what we're going to use. We're not going to really touch the other welding symbols. All you have are fillet welds. And from my limited experience in industry, although I was at Precision Cast Parts for 13 years, we didn't really deal with too many welding symbols. Mainly what we did amounted to fillet welds. But I need to talk to you a little bit about some of the other types of things, because it can be other than that. You can have a plug weld, which is basically kind of a hole that gets welded into and connecting metal. We're basically connecting metal and metal. And weldment drawings are typically the pieces that are put together don't really have to be all that accurate. We're not going to, because when you weld something, you're heating it up. And when you heat metal up, what happens to the metal? It expands because of the heat. And the weld gets done, and then when it starts cooling off, what does the metal do? It shrinks and contracts back down. So holding tight tolerances for a weldment, something that's just plain welded, generally fractions are going to be quite acceptable. And to a 32nd of an inch is probably pretty good for weldments. So it's typically pretty rough stuff that gets put together with welds. If it needs to be accurate, it's welded and then it might be machined after that, or ground, or some other kind of processing is included in it, just for welding's sake. We don't have to worry too much about that much accuracy in dimensioning. There's spot welds, which are done with a special type of machine. There's studs that are welded, seams, surfacing. There's grinding that can be done to make bevels, to make curves, to take away metal in the joint itself, which is then filled in with filler material. And there are different types of processes for welding. Arc welding is one, and TIG and MIG and tungsten gas, and a lot of different kinds of processes. But again, if you get in and around that kind of an environment as a drafter, you're going to learn those things. And it's probably going to be a few symbols that are used over and over and over again. So that's why we're not doing a whole lot with weldment drawings. But there are symbols for square joints and V joints and bevel joints, U joints, J joints, flares, flare and bevels, surfacing, and those kinds of symbology. The biggest thing about fillet welds is the fact that no matter if the arrow goes to the right or to the left, the orientation of the fillet is always the same. The straight perpendicular line goes up to the welding leader. It's always on the left side. And the angle goes up to the right. no matter what orientation the arrow's going. That's the biggest thing. What most drafters want to do in the classes I've had is flip this around and basically mirror image that if the arrow's pointing this direction, and that would be incorrect. The size of the weld goes over here on this side of the arrow, and then other information that might be included in the welding process itself goes to the right of the symbol. And again, spacing, your height of text should be 0.1 for the drawings that you're doing, and then you would proportionalize the size of this fillet weld according to that. So you might make that 1/8 of an inch, the vertical part of that fillet weld, and some of the other welds that denote different kinds of joints that go together. So you can look at that. If you get really extensive, let's see if I can sneak that in. There might be a lot of information that exists in a welding symbol. For most of the stuff that I've ever done, I've had this horizontal line and then the arrow that goes out here and points to the joint itself. And it might have a little tail on here. The tail can be used for something that says like 2 places or typical. TYP is an abbreviation for typical, which means that that particular weld and size of weld is going to exist pretty much on the entire drawing or at different other places. So I don't really need to have you worry too much about all of this kind of stuff here, other than the fact that when this points to a joint and the welding symbol and the size are down here below this horizontal line, that means that the weld is being applied to the side that the arrow points to. And it might be that's the only side. It might be just down below. But sometimes there's a joint on this side, and then there's a joint of welding on the other side with another piece of metal that's being positioned somewhere. And if there's information up here, that means that it's applied to the side of the weld that is opposite of the location of the arrow. And there's a number of other pieces of information in here. So this would be, this could be a fillet weld down in here, welding those 2 places together. And I've got a worksheet that I'm going to have all of you fill out, and we're going to go through that all together, which shows different types of joints, different types of ways that metal is being welded together. If it's welded properly, 2 pieces of metal that are joined together, if anything's going to fracture or fail, if it's welded properly, the weld itself should not fracture. It should be the metal that's on either side of that weld, because the weld heats up that metal, melts everything together, and fills in that melted area with filler rod. And where welds fail is imperfections in it. It's not done properly. It's too hot. It's too cold. It's welder doesn't know what they're doing, and that kind of stuff. Yeah. So that's on that. If you look at the next page over, a double fillet welding symbol. Again, the fillet weld is always oriented in this position. The vertical part is to the left, the angled part is to the right, and the weld size goes over to the left, no matter if the arrow is going this direction or this direction. The size of the weld is always here. There might be a weld that is a specific length. It doesn't go the entire length of what the joint is for one reason or another. And if that's the case, there would be a length that would be put in here. And really, that's kind of pretty much all you as an entry-level drafter need to be concerned with. Again, you might run into a welding job, and it's kind of like on-the-job training, on-the-job learning, because it's kind of really specialized kind of a situation. So chances are you probably won't have to worry that much about it. And there's all kinds of, let me drop back to this. The other things that I have run across before is a weld symbol with a level horizontal line and the arrow that goes out, and then a circle that goes around here. That means that there's going to be a weld that goes all the way around the particular joint, the pieces of metal that are being welded together. And a little flag like this that comes out with a little triangular filled in triangle shape up here, that means that that's going to be welded out in the field as opposed to being welded in the shop. And that's probably what you'll run into more than anything else in making a welding drawing. And then on page 675 is a chart of all the different kinds of welding processes that exist. I've done a little bit of welding in my lifetime, not much, and it's been years and years since I did any kind of welding. So I can't even begin to explain what all these processes are, and I'm not even going to try. But you can see that there's quite a variety of things that go on in welding, different processes, different ways of welding. All right. I don't want to give out the answer yet. So let me hand out these. 1, 2, 4. So get some kind of writing implement out. Pen or pencil will suffice. Make sure that you put your name at the bottom and the date in order for me to know who turned in the sheet and give you correct credit for it. All right, the top left. This is a butt weld. Generally the pieces start a little bit separated and held in place, and then the weld is applied. So the symbol for a straight, butted up together kind of a joint would be this. You draw a leader out, 45-degree angle or 60-degree angle possibly, and a horizontal line, and then 2 straight lines here and here. So you can see the illustration that it's going to be welded on this side, and it's going to be welded on this side. So it's welded here, cooled off a little bit, flipped over, and welded on there. And the gap that is supposed to exist is 1/8 of an inch.
Gap between the two.
The gap between the 2 pieces of metal. And then when this is welded and all filled in, it's like 1 piece of metal. And again, it's going to fracture out over here somewhere if it's all done properly. So this, the size, the gap is put here. That's not the size of the weld. The weld would be determined by the welder. It would have to be by whatever thickness the metal is going to determine what the size of the weld is. And that's all I need. It's 1/8 of an inch here. So this means that it's welded on the arrow side of the symbol, and this symbol and number that's up here means that it is welded on the opposite side of where the symbol is. And that's the meaning of those two, the significance of that.
So is the arrow like a full arrow, or is it just a half arrow?
It should be a full arrowhead.
Okay, just
Yeah,
making
it's, I hurried on this. This is probably one I filled out in class, and I didn't want to fill it out again, so I'm just holding it out.
sure. Fair
Should we
enough.
write 1/8 above?
1/8. Yep, can be just like that.
So again, the symbol on the side, the arrow is pointing, means it's an 1/8" gap on it.
Yeah, that means there's an 1/8" gap, this means there's an 1/8" gap. Well, if it's a butt weld, it's gonna be.
It's gonna be on both
It's gonna be
sides.
on both sides, yeah. Now, it might be that for some reason it's only welded up here,
Yeah. So the
which
symbol-
means that this would be on this side of the welding symbol only.
Okay.
But it's a butt weld, it would be welded on both sides. Usually. All right. Let's slide over to the next one. This one is this is a straight piece right here, and then this piece and this piece have a 45-degree angle ground on them. It's 1 inch thick. The information is that this penetration needs to be 1/8 of an inch, and this penetration is gonna, or the 45-degree angle is gonna go down about 1/8 of an inch on both sides, which is 1/4. So it's not gonna, so there's quite a bit of material left here, and that there's an 1/8 of an inch gap right in here and a 45-degree angle. So the symbol for that is gonna be, here's the size of the weld, penetrating down 1/8 of an inch on the arrow side and on the side over here. So that's been ground out. This 1/8 of an inch is for the gap that exists. A 45-degree designation at the top. So gap of 1/8 an inch, 45-degree angle on the grinding of it, and 1/8 of an inch penetration on the weld itself. So if you add those numbers up, if it's 1 inch thick and it's 1/8 inch penetration and 1/8 inch penetration, it's not gonna go all the way through. Which would surprise me to some degree. But that's the information that we have to work with, and that would be the welding symbol. Next one down is a fillet weld. Generally pieces that are at right angles to each other. This one says that it's gonna be a 1/4 inch weld and a 1/4 inch weld, so it's gonna be symmetrical. And the only symbol that is necessary on that is to go here with a fillet weld. So notice the orientation, the vertical part to the left, this going up to the right, and the size of the weld is 1/4. What this means is that this weld is applied to this side of the symbol, which means it's only welded on this side of the two pieces. There's nothing over here on this side. Red.
So is the idea that the flat side is facing towards where you're gonna weld, or is it that the curved side?
This side right here?
Yeah,
No, that's just where the orientation is.
okay.
It's not necessarily relating to how the weld,
So if the
Yes.
weld was on the other side of,
Over here?
right there,
It
and the
would
thing was
still
going
be
out the
this
other way, the flat side would still be on the
it
left.
would still be on the left side. It's
Okay.
always on the left side.
Gotcha.
But they would be facing upward.
Huh? Yeah, it would be facing upward.
If it was on the other side, it'd be facing up?
If it's on the other side, and since I don't need this ever again, if this had a weld over here,
Mm-hmm.
that's what you're asking,
Yeah.
right? The symbol would be this.
Okay, so on top means on the left and on the bottom means on the right?
No, on the bottom means it's on the arrow side of the symbol. Because I could put a welding symbol over here instead of over here,
Right,
if I had enough space. So if I put a welding symbol here, and if it was welded on this side right here,
mm-hmm.
then the symbol would look like this. And I'd put 1/4 of an inch in.
Okay, so you put it underneath if it's on the same side as the arrow. If it's
Correct.
on the opposite side of the arrow, you put it above.
Correct.
Okay,
Correct.
gotcha.
All right, this one here is has an angled ground on it of 30 degrees and a 1/2 inch and a 1/2 inch fillet weld on this side. This weld goes in 3/4 of an inch, so that's the size of the weld. So one welding symbol can be placed out here, and a line that goes, that's a horizontal line in case you didn't realize that. So the fillet weld is on this side, which means that the fillet weld is on the arrow side of the symbol, which is going to take into account this fillet weld right here, and the size of it is 1/2 inch. On the opposite side over here, we're going to grind this out to kind of create a fillet in there, but the symbol is this, which means it's ground out at a 30-degree angle, and the penetration size of the weld is 3/4 of an inch, which means it's going to come in 3/4, 30-degree angle that's grounded. So it's not a fillet weld because this is flat across here. But to get the penetration that's needed to make this strong enough for whatever the design is, we're going to grind out part of this. And again, it's ground in this direction, but the flat side of the welding symbols are always to the left. It has no relationship to pointing to the weld and orientation of what the weld is itself.
To get off topic, but I've seen different versions of how the fraction is written, either at an angle.
Yeah.
Which is the preferable? Which do you prefer?
Whatever's easiest to put in as text.
Because it's mixed matched on mine, but I didn't know if you had a preference or what.
No. It could go either way, quite frankly. It could go, vertical like this, or it could be more not stacked. Again, welders aren't too particularly fussy about how the fractions show up. They just need that basic information. All right, next one down has 2 fillet welds that happen to have some different sizes to it. This one is a fillet weld that's 1/4 inch. This one is a fillet weld that is going to be 3/8 of an inch in this direction horizontally and 1/4 of an inch in this direction vertically. So again, I'm going to put out the symbol, horizontal line, fillet weld, flat side to the left, angled up at a 45-degree angle. 1/4 by 3/8 and 1/4 inch. Brent, kind of to answer your question, I probably put them more vertical because of space limitation,
Okay.
more than anything else, because I was filling these out as we were going. This means that this weld is on the arrow side, 3/8 by 1/4, and on the opposite side, away from the arrow, is the 1/4 inch. Nick?
You know, if you've got the two different measurements, like the 1/4 by the 3/8,
Yeah.
the first 1/4 mean specifically it's only going up 1/4, or can people flip flop that?
I think, I'm not sure, to tell you the truth.
You're gonna ask.
Yeah.
They seem particular.
There might be a particular method in that, but I'm not aware of it,
Okay.
I guess at this point. All right, so here's a V that's been, I'm gonna run out of room. It's been ground in, and then it's gonna have a back weld on the opposite side. So it's a 45-degree angle on this piece and a 45-degree angle on this piece to get my 90, and it's going to penetrate 3/4 of an inch. There's going to be a 1/4 inch gap in between them to fill in with material with a back weld. So this is one way that I can do it. I can run the leader up and the horizontal line, and then this means that this information of the weld is applying to the arrow side of the welding symbol, the angle, that it's a V, and the size, which would be the penetration in here, 3/4 of an inch. And then this is a symbol, kind of like a little half circle up here for a backfill, and a 1/4 inch. And it can be done in this manner, or as an alternative, it can be done looking something like this. Now, this arrowhead would be in this position right here, but I had to move it over, okay? So again, my angled, my ground out angled piece 90 degrees and 3/4 of an inch. And then I could extend this on further, maybe not quite so high, maybe out in here somewhere, and put in then the backfill symbol, 1/4 inch, so it's above the horizontal line, which means that it is being applied to this side of the weld joint over here. Any welders in here? Am I doing okay so far? Oh, good. Let me know if it's wrong.
No, you're doing fine.
Okay, I wanna make sure that I'm getting the right, so maybe to answer Nick's question, does it matter on here? Which,
It doesn't really matter.
yeah,
It doesn't matter what you.
there's probably some other notation in there if it's really critical, I suppose.
Well, the whole thing is that you basically can tell, like, when you're building it, like, which side gets the thicker part of the
Yeah.
weld than the other.
Right, okay. Right.
Welders' discretion.
Well,
Good, we're doing
especially
great.
the metal thickness too.
All right,
Right,
so
right.
let's slide back here.
The thinner metal
The,
will be thicker.
the thinner, leg will be the thinner side of the
Where are we at? Okay, here we are. All right, 1/4 inch fillet weld here, 1/4 by 1/4, 3/8 by 3/8. Leader, horizontal line, fillet weld, 3/8 and 1/4. The 3/8 is applied to the arrow side, 1/4 inch is applied to the opposite side of the weld. Oh, I opened up the other one too. And another fillet weld. Let's see, what did I do here? So 1 inch and 1 inch, 1 inch, 1 inch, and a penetration of 3/8 of an inch here. So for the arrow side, we've got a fillet weld symbol here, and the 1 inch, which covers this size. And then on the opposite side, we have a ground out piece right here. That's what that little dotted line is. So we're gonna grind this out, weld this first at 3/8. Then we're gonna come back in and put in a fillet weld that's 1 inch on the opposite side of where the arrow is pointing to. So I'd pull this line up here and add that in, which says, do this first, then do this second, and cover it over. Which means there's some other work to clean out the slag if you're doing that process. All right, last two. Are we gonna make it? All right, so we've got an overlap joint that's 3/8 of an inch plate on top of 1/2 inch plate. Now, I've always said that kind of the rule of thumb, Sasha can back me up on this one or not, because you did the welding program, right?
I did.
Yeah, so she's qualified. Okay. Rule of thumb, if you don't know what size the weld is supposed to be, you'd go with the thickness of the thinnest material. Because you don't want to penetrate further than that. So we've got 3/8 over a 1/2 an inch. And I got a fillet weld that's going into the 3/8 and the 1/2 inch material. So I'm going to use the thinner material thickness as the size of the weld if I am not told or if I'm not, I don't really know what it is. Which means, now, here's another thing. I don't have enough room over here. Something else is going on drawing wise. I can start bending the leaders to get to where I need to go. They don't always have to go in this direction or in this direction with just a straight line. And I've made some kind of interesting little jogs in my welding symbols sometimes to accommodate what I need to do. So here, it's coming down here. This is the arrow side, which makes the fillet weld 3/8 of an inch here. And then on the opposite side of where the arrow is pointing, as a fillet weld, it's 1/2 an inch because, will that be true? Or would I need 3/8 on that one too? Because it's going up into the 3/8. No, because it's 1/2 an inch for here. It's only going to penetrate.
It's because it's a thick.
It's a 1/2 an inch this way and this way. It's not going to penetrate that far. And a surface buildup. Piece of equipment's worn down. We want to put more surface area on it and then kind of machine it back to make it a certain diameter potentially. So we're gonna build up this surface an eighth of an inch thick. So on the arrow side, we're gonna say 1/8 of an inch, and this is a symbol for build up. And then this right here indicates that it's going to be all the way around the whole diameter. To build up that surface up. A lot of those are gonna cover any kind of a situation that you're probably gonna run into unless it's more specialized. Like maybe you end up working at Big or Oregon Iron Works or something that does a lot of welding.
I feel like finishing marks are harder to understand than welding symbols.
What is?
Finishing.
Oh, finished surface marks?
Surface
Yeah.
marks, yeah, those are the harder.
Sam?
Would there be an instance where you would use the all the way around if you're like butting up two pieces of like 1-inch steel, where you would go all the way around the two bar steels? Or is it only on circular? pieces?
No, it's not necessarily on circular. It could be two pieces that are perpendicular, and one piece is a little smaller than the base. So you might have a horizontal base and a vertical piece that's inset a half an inch or something. For the purposes of the design, you might want to weld all the way around all four sides. Well, you don't want to put 4 different welding symbols on there, because it's going to be the same size fillet weld, more than likely, and you just want to say that size goes all the way around. If it goes out flush to the ends, you're just going to do 2 sides. In a flat piece, I don't see that there would be an all around on that necessarily. That, not unless it's some obscure thing. All right, any other questions? Yes.
The length is, welding length in the last case is not necessary.
Oh, the length?
Yeah.
Possibly. I mean, this is an example that I, was made up ahead of time. And yeah, let's say this might be 6 inches, and maybe I only want 4 inches of that build-up area. So yeah, out here I might put a tail on that, the little 45-degree angle here, and say length of 4 inches, or I could conceivably put a length, extend this out a little more. And I could put a length in here, like that. Yeah. So, all right. Now, just for the fun of it, here's some interesting alternative weld symbols. Unofficial weld symbols. Arc welding is a process, so there's a symbol for an arc weld. A tack weld is to hold something temporarily together, so you'll probably want one of these. A tack weld. A fillet weld, well, in this case would be pronounced fillet weld. So that's our fillet. A plug weld has a plug. A gas weld has a little gas cylinder. Spot weld has spots sitting up there. Spot welding is usually, again, kind of to hold things together but not do a whole lot of. Spot welding a lot of times is thin material, like sheet metal. Submerged arc welding, symbol.
I like the little gift.
Yeah, butt weld and flush weld. Flush welds are usually ground down so that they're flush. MIG weld, that's another process. So you can recognize the Russian MiG jet there. Keely arc weld, propeller. And then anything that's welded out in the field gets a field weld. So those are unofficial alternative welding symbols.
Well done.
Well done.
For your,
Universally.
universally understood.
Some of the time they use it.
Pictorial, I guess.
Pictorial.
Yeah. All right, ready? Drum roll, last project. Yeehaw. Just 2 drawings. 1, 2, 3, 4. Yeah, that always gets a chuckle.
Compared to everything.
Do that. Well, too.
All right.
Oh yeah, since I've got a fair amount of students here, and the question kinda came up. A certificate is what you're going to receive when you complete all your courses successfully. You do not actually get a suitable for framing piece of paper. And I only found that out recently, because I thought you did, but then I've never gotten a certificate from PCC, so how would I know? I just teach, and assume that you're getting a piece of paper. They only send you something suitable for framing if you get a 2-year degree. Sorry. And even a 1-year certificate, you wouldn't get a piece of paper. It's officially recorded in your transcript, somehow, some way. I have no idea how that shows up, but it will show up. And if you're so on a resume, you would say that you have completed the CAD certificate, computer-aided design drafting certificate, and you would, if they wanted proof of that, I guess you'd have to submit them a copy of your transcript.
So since you took the advanced AutoCAD out and we were able to take the digital design and 3D printing, that hasn't actually shown up on the transcript thing, that it's passed?
It
and that
will.
Okay, it will.
Because I have submitted the paperwork necessary for that to the evaluator.
Okay,
And he's emailed me back that he's applied the substitution.
okay.
And I just haven't opened up that particular email to make sure that it's gotten applied to everybody that it needs to get applied to. I've sent him like 20 substitution forms, and I've kept copies of those, so I will, between myself and Justin, we'll make sure that that actually gets transferred over.
Thanks for asking about that.
Yes, so I guess my thought is don't despair yet. Yes, 199 or 105 substitutes for the advanced AutoCAD class, which got taken out this year with this class. I mean, this group of students. So,
I got the email that was like, go order your diploma or certificate or whatever.
but according to what the evaluator said, you don't actually get it. So I don't know. I think it's just a generic email that goes out for
Somebody who's completing something.
degrees or certificates, but his statement was you don't actually get a piece of paper. Okay. I digress a little bit.
If you wanted a hard copy, that's probably.
Yeah, you probably have to pay for something.
Yeah, when you get transcripts, you do have, if you want an official.
If you want an official transcript, yeah. I'm not sure companies would really care.
Yeah, a lot of them just take unofficial ones unless it's.
Or they just take your word for it.
Yeah.
And then
Yeah, or you.
then
hang it on the
later.
wall if you buy or
That's
something.
just like pulling hairs, really.
Yeah, all right.
Getting 86.
An orthographic drawing, full size, with necessary views to totally describe the objects. Include the appropriate welding symbols, and I can tell you right now, it's gonna be a fillet weld. There's nothing else involved with that. Weld joints are to be 100% full-strength fillet welds. Pay attention, that would make a great note on the drawing. Note, 1/8" tall lettering, under that, 0.10 height, Arial font, full font style. Weld joints are to be 100% full-strength fillet welds. Please put that on your drawing, so I don't have to put the red line, that 100%.
100% what?
And have you.
It's just the second.
It's just the
The
second
second
sentence
sentence.
in here.
Third.
Well, actually, third.
Yeah.
Third sentence. Show all necessary dimensions. Show all necessary dimensions as to location of features and position of pieces that are put together. I will explain that a little further. And proper weld symbols. Include any appropriate notes. Now, you're the drafter, and there's a certain amount of things that they'd kind of like for you to be able to figure out, even as an entry-level drafter, in figuring out what the proper sheet size should be to avoid crowding, but also to avoid large amounts of wasted space. This is 1-to-1. We're not going to scale it, so consider that in your proper views, necessary dimensions, notes, and all that kind of stuff. All right. If there's tubing material, which there isn't, it would be ANSI 1026. Bar stock and plate is A36. That's not tubing. That's a piece of solid stock that's been drilled out. Okay, I'm just saying. So that's going to be A36. All right, there's a ambiguous little symbol here that's really hard to read on your paper and also right here. It's a P with an L through it, which is an drafting abbreviation for plate, which is the A36. Where's my marker? Covered it all up. All right, it looks like this.
Oh, that thing.
Letter P with an L in it. You can do that with two single line text
Oh.
commands. Single line text, P. Single line text, L. And move it so that it positions itself, okay? It's not that hard.
What does that mean?
Plate. It's drafting abbreviation for plate. Because I don't want to have to spell it all out. It dates back to hand lettering. I don't want to letter out P-L-A-T-E when I can go P-L, just like I did there. So I'm doing it by AutoCAD. Two single line text will take care of it. Once I have that there, I can copy it, or I can make a block out of it and put it on another drawing, or use it for later referencing. All right, the title, Weldment Project A, the drawing number CAD 265 WP, Welding Project -A. Weldment Project B, drawing number CAD 265 WP-B. Due at the start of class on Tuesday, May 30th. That's next week. This is 2.5 inches OD, outside diameter, by 1 inch long. Oh, excuse me, 1 inch. I can't even read. 1 inch ID by 1.5 inches long. This is plate 3/4 of an inch. The first dimension is the thickness. Second dimension is the width. Third dimension is the length.
3/8.
This is simple enough that you could put this on as leaders. This means that all of this is symmetrical along this center line. And it would be best if you did a front view and a top view, so that we get the correct orientation. Red.
And you want them to be kind of exploded views, or whatever you
No,
call it?
I want them to be connected
Joined
together.
next to each other.
This is only exploded as an illustration of
Okay.
how these things go together, that they're separate
So
pieces.
you want the two plates to be tangent to the circle, basically.
Correct.
Gotcha.
And then a fillet weld. And I might even sketch it up here for you, just to help you. I mean, I'm such a nice guy. All right, that's one drawing.
You doing it in AutoCAD, Mr.?
I would, personally, but if you wanna use SolidWorks or Inventor and create a solid model and then make a drawing of it and use the welding symbols that exist in there, that's fine. I don't care the process, I just care the end result, print.
The dimension on that is at place 3/8?
Yes, this is PL
That's, okay.
for plate, then 3/8, which is the thickness by the fact that it's 1.5 by 1.5 square. Okay, the other one, so this is A, obviously, because there's an A up here, and this is B down here. Do I have it all on here? PL quarter, which is the thickness, by 1 3/4, which is the width, by 3, which is the length. On this one, I want you to dimension the size of it, not use a leader to show the dimension. And this note right here is for information purposes. 3/4 inch diameter centered on the plate. Do not use this note to locate this, that is inaccurate and assuming some things that people actually know where the center of the plate is. Location wise, you should put in a dimension from one edge to the center of the hole and from one edge to the center of the hole, which means you're going to have a top view, which means you're going to have some hidden lines. This is also plate, that's the PL, 1/4 inch thickness, 1 3/4 width, 2 3/4 length, a 3/8 inch chamfer on here. Dimension the location of the hole, both from the bottom and from an edge. Don't make the assumption that people think that that's in the middle. Dimension it and take away all doubt and controversy that it gets skewed over somewhere. This line right here means that these two holes are in line. You could, with your diameter of this hole right here, which is a 1/2 inch diameter, you could do a diameter dimension off of there, and you could say 1/2 inch diameter, 2 places in line would suffice to show that this is not any difference. So once you have this dimension on here, then that would go to that. I would suggest front view, look in this direction, top view, and then a right side view to get those dimensioning, required dimensioning in there. This plate is inset 1/4 inch. There would be a fillet weld on this side and a fillet weld on this side. Now, you could put one welding symbol over here with a fillet weld and a fillet weld, and then put the little angle out here and say typical, or say 2 places. All right. Any questions with that? Yes, Kevin.
First drawing, you want fillet welds on both sides, is it like?
Yes. Top and bottom on, yeah. All right. So let me do this. You may want to hit on full back there, so I don't have to walk back there. Top one.
Typical 2 places, which one was that,
Well, hang on. Proper center lines. Now I think, as I recall, that if you use SolidWorks or Inventor, it actually puts in a funky little welding thing in here. Maybe that's why I don't like it, because you don't do that on, if you were just doing AutoCAD, you wouldn't put anything in there to indicate that that's a weld. So you can do this for the welding symbol. What was the thickness so that like creates, yeah.
Symbols in the-
Okay, so, you know, what I might do is actually horizontal like that with single line text. And then you could say this. PLCS places. That means, oh, let's not forget the arrowhead here. That means there's gonna be a fillet weld here, and here, and here, and here. And because this is all symmetrical and it's got definition of the size, you could do a leader to say what the size of this is, and a leader to say what the size of this is, and then you're gonna include your top view. There really is no dimensioning involved in this. It's all, this is supposed to be all along the center line here. Then the other one, let me just do the front view here, maybe. Something like this. Don't forget that it's got a line in there for your chamfer. Where's that hole going? Above the chamfer? Yeah, I think it's above the chamfer. Don't forget your center, your hidden lines. You might have to change your line type scale to get it in there. Don't forget your center lines. Oops, I got it out of proportion here. And there's a hole up here. Don't forget your center lines. Alright, so you're gonna make sure that you're gonna dimension this. This is one of those kind of rare occasions when we have to put a dimension on the face of the object. And we could say quarter. Yeah, let's do it this way. I could either say typical or two places, which means it's here and here. So if I do that, then that leaves me room to put my welding symbol out here. Is that correct?
Yes. Quarter.
Quarter. Typical or two places works. Either one. I mean,
So we could do tip on the other one too? Instead
over
of
here,
right
yeah, you could put that, or you could say typical.
side? Alright.
Works.
Two places.
Right, then a top view and a right side view to get your dimensioning, size, and location.
Okey-dokey then.
And over here. Don't use the generalized note centered on the plate. That's it. Sorry to have such an extensively huge project for your final one. You got some work to do for making red line corrections anyway and getting that trolley wheel assembly thing done. A couple of you still have other things to do. Question, Abraham?
Do we need a side view for that separate?
Do we what?
A side view?
Over here?
Yeah.
Yes, you would want a right side view as well because you need to dimension the location of this hole right here in the vertical pieces. Yes. Correct. All right. Ready, set, draw. Get your work done. Finish up.